Hey y'all, it's Steve, Hobo with Wood, and today I'm going to talk about how I have refined my inlay process. I'm still learning, but I've learned quite a bit, and they're looking pretty good. So if you're interested in knowing more about how I do my inlays, you're going to hang around, watch this, don't skip around, because I do up here, and you're liable to miss something really important. So if you want to learn about Hobo inlays, stay tuned. If you're not familiar with inlays, it is just what it sounds like. You're inlaying another piece of wood into another piece of wood. Now, I've done this in the past where I've completely cut out the inset where it was completely cut through, and then just cut out the next piece and inlaid that in there like it's a puzzle piece. And the problem with that is you see it here, and then when you flip it over, you see the other piece too. And that's an inlay, but it's not an inlay. So this is an inlay because you've got that nice solid thick walnut with no evidence of it at all on the flip side. Now you do that by creating a pocket in the wood that's going to receive your inlay, then cut out your pieces and then glue those into place, and then sand it flush and finish it, and you get a really nice piece. But there's some tips and tricks I'm going to share with you on how to create that pocket and to get your best fit, and the techniques that you're going to need to do in order to test your laser to find out what your settings need to be on the material that you have in order to create this project. Because my settings aren't going to work with your settings on your laser, because this is something that's really going, in fact, anytime I do this, this is the technique that I'm going to do before attempting the project. And I've videoed this whole process. This is one of the pieces that was a fail. But there it is with the pocket and a couple of the pieces that were inlaid in there. And these I did with adding some kerf to the puzzle pieces, and it was too tight of a fit. And I'll talk about that later in the video. But, you know, a lot of trial and error to get this figured out. But then I got a really nice piece that I think I'm extremely happy with, for only about my fourth or fifth attempt at doing this. So the first thing I do is I take the wood that I'm going to be using as my pocket, that's going to have the pocket in it, and I create a test burn pattern on it. I'm looking to see how much I can remove at one time without any evidence of an engraving on the reverse. Now, in previous attempts of inlays, you may have seen the video where I did this, and I approached it by doing a light engraving, and then a flood fill, a light engraving, a flood fill, several layers to remove a little bit at a time and clean it out as I go. But that just took too long, and I'm impatient. That's why I got the CO2. I'm impatient. But I did this with the diode. I did this with the 10-watt Comgo Z1. And what I was looking for was how much I can blast out of there like a sledgehammer in one pass, do a slight clean, and then do my inlay. And what I'm looking for is how deep I can go. Now, like I said, here you can see it's cut all the way through and burned through, and I don't want to see any evidence of that. And I noticed a second ago on the video that it looked like there was a mark where there might have been a potential burn through on my pocket. But that was a fudge, a fingerprint. I cleaned it up because I know there's a troll out there that's going to go, well, I seen there was some burn through. No, there's not. This is This is perfection. Because as I've said in other videos, I'm perfect. I'm perfect in the way that I promise I'll screw up in this video again too. So, there's no burn through. This was accomplished by doing this. Now, this was 1.8 millimeters thick. When you do your inlays, you need to account for the thickness of your piece that you're going to inlaying. You also need to account for the glue and any potential swelling that's going to take place as you glue that in place. So I wanted something about 2.2 millimeters deep. 1.8 plus some room for error, so I went 2.2 millimeters. So once I've got this test cuts and burns, I'm able to use my micrometer with its plunge feature. If you've not used plunge, you've probably used these to measure the thickness of your material and say, okay, oh wow, okay, yep, that's 3.3 millimeters, 3.3. Well, right down here is your plunge gauge. As you stick that out, there's your plunge gauge. So you just push that out and then come in here to one of your pockets that you've cut out and then push it back in. And as you push it back in, it's only going to go until it can't go any further, and then you can see how deep it went. So I looked for 2.2 millimeter deep engraving with one pass as fast as I could with no evidence of any burn through. Once I've got that speed and power, then I went in and created my pocket for that inlay. So now let's talk about the technique that I used when I'm burning my pocket. So I've got my speed and my power to achieve that 2.2 depth that I want. But I didn't just do that engrave. I need this pocket to be as clean and as precise as it can possibly be. So I've done an initial engrave that burns away that pocket with that sledgehammer. Then I went back and I've got my notes sitting here. The initial engrave on this particular material was 50 millimeters a second at 60% power on a crosshatch. Then I did a line after fill at 40 millimeters a second at 30% power. With me? So horizontal, and the crosshatch vertical, and then a line after fill. Now the line after fill is to do a very defined chiseling around that perimeter of that pocket. And then lastly, I did a flood fill. Now this one was my first attempt, and in the video that I hope to have uploaded on here, you can see that I do the crosshatch, the line after fill, and then while it's doing the flood fill, the laser just quit. I had a setting issue that I had to address, and I've got that corrected. It was a programming error, but you can see in the video the difference between the engravings that had the flood fill and the piece that didn't. Now the reason I do the flood fill is I think of it as doing it using a pressure washer. I'm doing it at a much lower speed and at a much lower power. But you can see a very distinct difference between the pieces that got it and the piece that didn't. Because what it's doing is it's taking and pressure washing, blowing away, lasering away all of that residue, the residual, the soot, and giving a real clean surface for my glue and for the adhesion of that inset, the inlay, to go into the pocket. It's just cleaning it up. So the settings I did on this was 3.3 millimeter hard maple. It was a 50 millimeter a second speed at 60% power on a 10 watt diode in a crosshatch. So I'm burning it horizontally and then vertically. Followed it up with a line after fill, 40 millimeters a second at 30% power. Then followed that with a flood fill of 40 millimeters a second and only 30% power. So the line so my line after fill and the flood fill were actually the same speed and power, but much reduced from the initial pocket. The walnut, which was 1.8 millimeter, was cut at 5 millimeters a second and 100% powered. and no kerf. This one was a failure because I added 3/100ths of a kerf, and that 3/100ths was enough that it didn't want to fit. So the successful piece was done with no additional kerf at all. Okay, so some of you might be asking, well, what is kerf? Kerf, K-E-R-F. Well, many of you already know what kerf is, and you probably know more about kerf than I do, since I'm still learning all of this. But this is my understanding of kerf. Originally, people discuss it when they were talking with actual woodworking with saws. And kerf is the amount of material that is cut away making your cuts. It is that wasted area. So if you were using a radial saw or a table saw that was 1/8 of an inch thick, and as it cut, it left just that amount of a gap, well, you had 1/8 of an inch kerf. So when carpenters were building and they were talking with each other, sometimes you might hear them cut the line or outside the line, inside the line. Well, that's what they're referring to. They're referring, when you measured and marked that material, where do I need to cut it? Do I need to cut outside the line to allow for the kerf? Outside the line is the actual length you need, or cut the line and you've taken into account when you measured and marked it what that kerf was going to create. Well, here we're not working with any physical blades that are going to create kerf, but the laser does create waste as it burns away and makes your cut. And there are tools that you can actually get and measure your groove and to find out what kind of kerf that you're actually creating with your specific laser. But unless you're doing something that's a $20,000 piece of project or 5,000. Does it really matter exactly if it's 8 thousandths or 10 thousandths? As long as you get it to where you want it, does it matter really? And that's trial and error, and actually that is easier than going and buying the tools, figure out how to use them. That's why I do all these tests to find out what this material is going to do with my laser, because every material is going to be a little different too when it comes to how much power is going to be needed to create the pocket. But the kerf's going to be pretty consistent. But I will test, even test pocket before I do an actual project. So just like doing my depth burns, this is 2-letter F's done with the same font, the same image in LightBurn. This one just has a lot of additional kerf added to it. So it went way out beyond the lines. And of course, that was now too fat to even fit in the pocket. So how do we create kerf? Well, it's a real easy setting in LightBurn, and it doesn't require changing any aspects of your fonts or your images. It's all in the cuts and layers. So let's jump into LightBurn real quick, and I'll show you where that's at if you're not familiar with it. And then we'll jump back to the project. So here, I have the letter F, and I need to add kerf to this. I want to make it a little bit bigger. Well, if you go into your cuts and layers, since you're cutting out the perimeter, you're only in align mode. You're familiar with where your number of passes are at, and you may not have paid any attention to your next option. Here's your kerf offset, and we're in millimeters. Our unit of measure is metric, and here it's asking us kerf offset in millimeters. If you don't see it in millimeters, you just cancel out and change your unit of measure up here from your inches to millimeters and go back in, and you'll see now it's in millimeters. And that's important because whenever you look at your laser's specifications from your manufacturer, they will tell you, in this case, it's a 0.08 kerf. Well, that's 0.08 or 0.08 of a millimeter is what they're saying that kerf is. But there's also another issue with your kerf on lasers. And this is my understanding, not all laser beams cut in a circular pattern. Wrong button, stupid. There we go. I told you I was going to make mistakes. So with the circle tool, when you get the a laser beam that's a perfect circle, as you're moving around this perimeter of this letter F, horizontal and vertical, the transitions from one to the other, it's going to be at perfect cylindrical shape because it's a perfect circle. Well, it's my understanding that not all lasers cut that way. Some laser beams, again, there's another mistake. Some laser beams actually cut in a rectangular pattern. And it has a thinner horizontal than it does a vertical. So where that's a problem is now if your laser beam cuts like this, you're going to have a real thin kerf as you go across the top of the F. Then when you come down the side of it, all of a sudden it's gotten larger. So it's important to know, what your kerf is, and is it a symmetrical kerf? Because that's going to make some determinations on how you use your kerf. And that's if you want to get really, really Pacific. I kind of like going Atlantic and just kind of getting in the water. I got to be close. I don't care if it's Pacific or not. But, so the way my mind wraps around this is supposed to be a cylindrical 0.08 kerf. So the very center of that would leave 0.04 on either side of that laser cut. So if I wanted to have the tightest possible fit, an exact fit would be a 0.04 outward kerf. And here it tells you, because I used a positive number there, that went outside the line. So that would have made it extremely snug and been a perfect cut. And it was too much. I actually used a 0.03 and it was too tight. It wouldn't work. I could have done a 0.02 or 0.01. I went ahead and just did 0. But if you're doing a project where you need to decrease, you want to have more kerf, then you'd use a negative number. So a negative 0.04. Now you see it switched to an inward kerf. It's cutting away even more material than what you have on the screen. So there's my limited understanding of kerf, and it's probably just enough to let you know a little bit, but also confuse you and probably make things more complicated. But that's what I'm here for. Okay, so now let's talk about the flood fill technique. Since I can't get in there and sand the pocket smooth and I want to get all that debris out of there, I just wait a few more minutes and let it run an extra flood fill, blow all the debris out of there, clean it up, give a really light engraving of that final texture. And on this image you can see in this job there was an issue with the programming that caused the laser to come to a halt mid-job, but it almost finished. It was down to the last letter of the flood fill. And you can see a distinct difference in the image there where the letters that have been flood filled are really nice and clean and show no soot and debris, while the last one there, I think it was the 7, is still really dark and full of debris. Another really big tip that probably a lot of them are going to miss out on because they've already checked out. Whenever you're deciding your initial plunge depth, your initial depth of engraving, like I said, my walnut, my inlay was, I think, 1.8 millimeters thick. And I decided to go with a plunge depth of 2.2 millimeters in material that's 3.3 millimeters. Now that's about as deep as I could go without starting to show any burn through. And also, there's the tip, you gotta leave it proud. You want your inlay, you want that piece to be proud, to be above your original piece when you glue it together. Because you can sand that smooth, or if you're really proficient and you got a nice wood shop, a good wood plane. But me, I'm hand sanding right now. But you cannot put more material in once you've sanded it down and you've got a valley in your inlay. So you want that inlay to remain proud when you do your assembly. So when you're picking your plunge depth, you want to take into account the thickness of your inlay plus a little bit of room additional for the glue, and the fact that you're not going to have a perfectly flat surface that you're going to. There's going to be areas of wood grain that are still going to be proud in your valley that's going to keep that elevated. So leave it proud, but you want it to be in a situation where you're having to remove as little product or material as possible. Now I'm working with solid hardwoods here. This is solid hard maple. It's not a plywood. If you're trying to do this with plywood and veneers, it ain't gonna work, because by the time you get all that sanded down and sanded smooth, you've sanded through the veneer and it's not gonna be a nice pretty finish. So I'm working with trying to get a hookup for me, for you, on hardwoods, ready to use, dimensionalized hardwood in 1/8 inch, 1/4 inch. You can do up to 1/2 inch if you're doing CO2s and stuff. But for us diodes, 1/8 inch, 1/4 inch. 1/4 inch is ideal for doing inlay. This was about a 1/2 inch. This is a trial piece, and I was able to put in the 1/8 inch upside down there, buddy. 1/8 inch. Told you, I'm perfect. That's 1/8 inch, I think. Bloodwood, I think. I can't remember. You need hardwoods in order to do these inlays and have them come out really nice and not be feared of sanding through your veneer on your plywoods. So that's a huge tip, like I said, that a lot of them are going to miss out on. A last tip: when you're going to attempt your first inlay, don't get crazy and think you're going to do this elaborate tree with all the branches or antlers on deers and all. Start with a simple font, a single letter. Just do the Arial block or black and a single letter, and practice finding your technique on finding that right depth, the right plunge depth, and the right offset and kerfs. Because you're going to go through a lot of material just figuring out the settings that are going to work for you. And you don't want to be frustrated with the fact that you've wasted so much material just getting it dialed in. So do it with one letter and do it several times until you get it figured out what's working, and then you step it up to a word and then an image. So don't bite off more than you can chew on your first project. So if you're still watching, thank you. I hope you find these informative, entertaining. I want to thank my Patreons. My patrons on Patreon. See, I'm still figuring all this out. Very appreciative of your support. If you find these videos informative and you take a little something from them and you want to help pay my power bill and buy my hardwoods to help create more projects, jump over to the Patreon page and sign up and become a supporter. It'd be greatly appreciated. Don't forget about the second channel, which is the Laser Maker's Realm, or Laser Maker's Realm. That channel is devoted to strictly free projects. Here I hope to help share what I've learned on how to do techniques, but Laser Maker's Realm is just a channel of free laser projects from me and 2 other collaborators on the channel, so you're going to have a lot of different ideas. All free. Did I tell you it was free? So thank you for watching. I'm Steve, Hobo with Wood, and I'll see you in the next video. Until then, I'm out.